Ramanujan for G is now available on the Google Play Store. Try it out for free.
Morning class. Okay, so in the previous lecture for the permutations and the combination, we have seen up to the with repetitions case, right? So now we'll start with the number of permutation under certain conditions. Let me write PNC number of permutations under certain conditions. Okay, so the number of permutations of n different things taken all together when r particular things are to be placed at some r given places. So for that, the number of permutations will become n minus r p of n minus r, that is n minus r factorial. Okay. Next, number of permutations of n different things taken are at a time when m particular things are to be placed at m given places. Right? Similarly, number of permutations of n different things taken are at a time when particular things is to do be always included in each arrangement. Okay, so for that, r into n minus 1 p of r minus 1. Similarly, number of permutations of n different things taken are at a time when particular thing is never taken in each arrangement, which is n minus 1 p of r. Okay. Next, number of permutations of n different things taken all at a time when m specified things always come together is m factorial into n minus m plus 1 factorial. Next, number of permutations of n different things taken all at a time when m specified things never come together is n factorial minus m factorial into n minus m plus 1 factorial. Okay, so you can make a note of this and we'll look out at examples. Okay. Yeah. So next example. How many different four-letter words can be formed with letters of word Jaipur? Letters the word Jaipur when A and I are always included. Okay, so we'll solve. So since A and I are always included, so first we select two letters from the remaining four. So which can be done in 4C2. A and I are always selected. Right. So it will become 6. Right? 6 ways. Next, now these four letters can be arranged again, which is 4 factorial. That is 24 ways. So the required number will become 6 into 24, that is 144. There is one more way. There are four places we need to fill. So A and I we need to include. Okay, so these two are included. Now remaining two positions. For two positions we have J, P, U, and R. Okay, so totally four. So we can say filling for this is 4 and 1 will be goes out, so it will be 3. Okay, if repetition is not there, correct? So that will be 12. Then again you need to multiply with the whole because you can make different arrangements, so it will be 144 again, right? And if repetition is allowed, then total this place will have total 6 numbers, right? Because total number of letters are 6, so 6 and this will be 6. That is 36, and 4 different places, so 36 into 4, that is 144. Okay, next problem. How many different three-letter words can be formed can be formed with letter of word Jaipur when A and I are always to be excluded? So after leaving A and I, we are remained with the four different letters. A and I, then four different letters, which are to be used for forming the three-letter words. So that is 4P3. That is 4 into 3 into 2. That is 24. Okay. So you can make a note of both examples. and this one also. Okay. Next concept is circular permutations. Okay. First one is arrangements around a circular table. Okay. So of circular, the number of circular permutations of n different things taken all at a time is n minus 1 factorial if clockwise and anti-clockwise orders are taken as different. Right? Right. Next, arrangements of beads of flowers. Okay. So the number of circular permutations of n different things taken all at a time will be half of n minus 1 factorial taken this if clockwise and anti-clockwise order are taken not as different, right? One more case, number of circular permutations of n different things taken are at a time. So there will be two cases. If clockwise and anti-clockwise orders are taken as different, then the required number of circular permutations will be npr by r. And case 2, if clockwise and anti-clockwise orders are taken as not different, then the number of circular permutations will be npr by 2r. Okay. Next, restricted circular permutations. So in this, when there is a restrictions in a circular permutation, then for the first of all, we shall perform the restricted part of the operation, then perform the remaining part of treating it similar to the linear permutations, right? That will look out in the example. Okay. So first you need to copy this and all these three formula. Okay. Now copy this. Okay. Yeah. So let's look out at examples. In how many ways can 5 boys and 5 girls can be seated at a round table so that no two girls may be together. Okay. So leaving one seat vacant for the 2 boys, 5 boys may be seated in 4 ways, 4 factorial ways. So then we can write 5 boys seated in 4 factorial ways. Then at the remaining 5 seats, 5 girls any sit in the 5 ways, 5 factorial ways. So hence number will be equals to 4 factorial into 5 factorial, right? Note of this. Okay, next example. In how many ways 4 beats out of 6 different beats out of 6 different beats be strung into a ring? So in this case, clockwise and corresponding anti-clockwise orders will give the same circular permutation. Okay, so number will become 6p4 divided by 4 into 2. That is 6 into 5 into 4 into 3 divided by 4 into 2. So that will be cancelled out. This will be 3. So it will be 45. Similarly, one more example. The number of ways in which 10% can sit round 10 persons can sit round a circular table so that none of them has same neighbors in any two arrangements. Okay, so here 10 persons can sit a round table with a 9 factorial ways, but here clockwise and anti-clockwise orders will give the same neighbors. So hence required numbers will be half of 9 factorial. Simple. Okay. Next concept is combinations. So each of the different groups, each of different groups or selections which can be made by sum or all of a number, some or all of a number of given things without reference to the order of things in each group is called a combination. Meaning, each of the different groups or selections which can be made out of some or all of a number given things without any reference to the order of the things in each group, which will be called combination, right? So when we'll take example, you will get to know it. Okay, difference between the permutation and the combination. So let me write difference between permutation and combination. So first we'll write problems of permutations. Okay, first one is arrangements. Second one is standing in a line or seated in row. Third is problems on digits. Fourth is problems on letters of a word. Right? So problems of permutation based on arrangement, standing in a line, seated in a row, problems on digits, problems on letters of a word. Okay. So these are for the permutations. Similarly, part B, problems of combinations. First, selections and choose. Second, distributed group is formed. Third one, committee. And the fourth one, geometrical problems. Okay. So again, each of the different groups are the selections which can be made by some or all of a number of given things without reference to the order of things in each group, which is called the combination. Okay. So make a note for this first. Okay, next is problems of permutations again, based on arrangements, standing in a line, seated in a row, problems on digits, and problems on letters of a word. So make a note of this. Next, for the problems of combination, selections, choose, distributed, groupers formed, committee, or geometrical problems. So we'll start the problems and examples based on the combination will be in the next class. Okay. So for now, let's wind up the session here. Okay. So thank you guys. We'll see you in the next lecture.